Hey, how's it going, everyone? All right, so the plan for today is to leverage all of the things that we learned with our LSTM over the last week or so and adjust some of the parameters. I want to see what we can get from a loss reduction perspective. Can we make it better? How's it going there, Torva? Hey, welcome on in. Good to have you here. Thank you for all the work on the Discord bot. Merged the PR that you sent over there. There was a UV lock error that I fixed for you. Got that merged in. And you got it to work, Torva. Thank you. That's pretty exciting. You'll post the stream link in the Discord. Sounds good. Oh, yes, thank you. I keep forgetting about that because now we don't have StreamCord anymore. Because StreamCord is having some issues. If you saw the status on that, it was like error red for like a month or so. And it's crazy. I tried to recreate it on StreamCord. It gives me a 500 server error, which means their backend system's broken. Thank you for the link. I forgot about that because it's a new thing. I got to remember to do that going forward. Okay. Let's see here. All good to go. Yeah, we're all good to go. Okay, let's get into it. So where are we right now? Okay, I want to close all these windows out, and then let's take just step back and look at all of our code. So we've got all of our hidden parameters. We've done. Let's do a full review. So we generated a dictionary. Hey, Jinlu, good morning. Welcome on in. Good to see you. And we were chatting earlier today, weren't we? That was actually a lot of fun. I enjoyed that. It was neat to see what you're working on. The USB, that is a big task. USB is it's been around for a long time, and they've got a lot of things that go along with it. Yeah, about that, you integrated the mod management. Oh, that's right. We ran out of the storage on the bot, so the new features don't work. Oh, really? We ran out of storage? There's no way. There's like gigabytes and there's nothing to store. What, are you serious? Well, we'll have to take a look at that. Okay. So we got our dictionary, we got our tags. We build these up with a mask that we set at 0. So that way we have something that we can ignore, right? So because it's random data. We don't know what's going to be in the data. We don't know what the length is. It's the same thing for these large language models and transformers as well. We're using LSTM, which is a precursor to the transformer. Hey, Neva! How's it going? Good to see you. Happy Thursday. We're almost to the weekend, aren't we? It came fast. In the TOML, we have a limit set to 15 megabytes. Oh, really? Well, we got a lot more than that. There's no reason to limit to 15 megabytes. You can go a little bit bigger if you want. Feel free to bump that up. Make it a little bit more. Easy. Oh, yeah. Oh, for us in Israel, it's basically the weekend now. Oh, that's right, because it is Friday, right? Because Friday is the weekend, right? Friday and Saturday. And Sunday is the beginning of your week. Hey, Clips Merge, good to see ya. Welcome on in. It's fun chatting with you on the DM over there. Also, Kyle, hey, everybody's here. It's great. It's great. It's like the evening of the day before. Oh, got it. Okay, got it. Thank you for the party poppers, likes you guys. Friday is the weekend, and it's Thursday night. Exactly. So Friday and Saturday. Whoops, I forgot. Oh, whoa. I keep forgetting. It says it was looped. Loop. There we go. Pause. Uh-oh. 1 second. We got some audio issues there. All right, there we go. Okay, good to go. All right. Good to guys have you here. We're just getting a little bit of the audio thing set up. All right, so that is a funny. Oh, you're talking with a broadband company in here. Wait, what do you mean? Skywatch Telecoms. Oh, hey, it's Skywatch Telecoms. Now we're talking with a telco. Broadband company. I see what you're saying there. It took me a second to figure it out. Everybody's here. I know, right? It's like a Super Smash Bros. Ultimate. Oh, I love that. Oh, I played that so much with my brother. We played that game a lot. We played a lot. A lot of Pikachu, a lot of Marth, a lot of Ness, right? From, mashup of the century. It is, I know, right? That's great. So let's continue on with our learning of LSTMs. I just want to take us. You love that game? Me too. It's so good. Smash Bros. I played that so much. I played it with my brother all the time. It was great. We play, you play it like way too much as an adult. You still do? Yeah, my brother's on the other side of the country now, and I play different games now. Even Mario Kart is fun. Hey, sure is. Clips merge. It's really good. It's good. I need to get a Switch 2. I need to get a Switch 2. I don't have one. I have a Switch 1. I have the first Switch. I need to do that. I need to get a Switch 1. Mario Kart World is super cool on the Switch 2, right? I want to try that out. It's like open world, kind of, right? It's open world menu or something, right? As far as I can tell. You just drive around in the open world for, I don't know why. It's like a lobby. Open world lobby. Mario Party. Oh, right. Rusty Window. Mario Party. We're talking on Nintendo now, aren't we? Hey man, recently joined. What are you doing? All right, so we're building LSTM. We finished it on yesterday, and now we're gonna mess around with it. It's what we're gonna do today. We're gonna play with it a bit. Hey, Spider Moon Toby, you're here too. All right, good to have you here. Kartik, glad to have you here. We do software engineering on this channel. That's what we do. We're gonna look through all this code here. Lots of code. So much code. You made it. You sure did. You're just waiting for GTA 6. There you go. And then you go underground for a month. I think I'm gonna do that too. I think I'm gonna do that too. Wait, I looked right now. I swear we set a limit somewhere. Oh, really? Oh, well, I didn't know about it. I had no idea. 15 megabytes is nowhere near enough, by the way. You could definitely go bigger. The Game Boy sold as well as it did because it came bundled with Tetris. It came bundled with a game, you guys. Well, because you couldn't just get the console without a game because you couldn't do anything with it. Imagine all the disappointment if you got a console and you couldn't use it. Back when it was $89. Whoa. Such a good deal. Now it's like hundreds of dollars. Hey, John Spenick. How's it going? John, welcome on in. How you doing? We're doing great. I don't understand. I couldn't join the previous stream. Oh, really? Well, Kartik, all good here. So what we got here is a Pytorch application. We built an LSTM model right here. Really simple. If you look on the screen, there's not much to it. In fact, what is that? There's only 19 lines of code, right? 19 lines of code. For the model, the rest of it is all data manipulation. And there's 150 lines of code in here. How's it going there? A droid deck. Good to see you. And Cello Tape. How are you? We're doing good. Thank you for being in here, you guys. Trust me, I wasn't there last 2 streams. You missed the slot though. Hey, all good. Oh, hey, GCA. Good to see you. Hey, Stephen, quick question. Do I have contacts with people who have published papers in renowned venues like ICLR, Nature? You're targeting those for right now for your research pursuit. GCA, tell us more. Tell us more. Droidek, thank you for clicking the hi button there. 19 lines of code to create an Ultron. To create the Ultron. The ultimate AI. All the AI. Nice to meet you, my friend Droidek. Nice to meet you too. All right, so this is our LSTM right here. We got it to work really well. We thought we were being clever with our unsqueeze. And in fact, I do want to try, all right, so this is going to be a to-do item here. So we'll do this today. And then we're going to mess around with this because I want to see what the difference between view is with one negative one and an unsqueezed one, because I thought they looked identical, but apparently they're not. I need to see what the difference is. I need to see the difference. Stephen, could we see a WGPU stream? Oh, is that WebGPU? Now vibe coding it, and it's super cool how much performance you can squeeze out of it. Really? I need to learn more about it. All right, let's take a quick little look at it over here. It's a Rust library. Oh, really? Okay, wait, now I'm a little more excited because we were using the Burn library. You remember a few weeks back, maybe a few months back? And it was a bit much. It was like, you needed like a bucket of code. Just like, for example, here's Pytorch code, right? 19 lines of code, and you can get an LSTM up and running. It's the opposite. It was like hundreds of lines of code with the Burn. However, WGPU sounds like it could be better. WGPU Rust. All right, let's take a look at this. Let's take a look. Here we go. Let's zoom in on this. Let's zoom in. It supports my system. All right, good. It's like less annoying version of Vulkan. Oh, got it. Okay, so it's more direct. Burn had that as a backend. Oh, got it. Okay. Why did you stop your landscape streams? Oh, I didn't. We actually have them over here on Twitch. So you can go if you're interested. Stephen LB on Twitch. Here you go. There we are. Right here. See right here. You can see the inception here. A little bit of inception there. Yeah, over there on Twitch. If you guys are interested, the horizontal. Oh, GCA, you got cut off network just now. So do you have contacts with published researchers? No, I don't. Not really. I mean, I might. I don't know how and where to seek guidance for this. So from a networking perspective, I mean, I've got a lot of connections on LinkedIn. So I've got some connections on LinkedIn, though. That's as far as I know. If you find someone that I'm connected to on LinkedIn and you want an intro, send me a request on LinkedIn. Stevenception, or is it Blumception, right? Jinlu? Only boomers watch horizontal stuff. I know, right? It's not aimed at AI. It's like for graphics and lower level stuff. Never. Oh, got it. Okay. I was wondering about that. It might be fun. It might be fun to look into anyways, because I'm like really into the AI part of the picture. Is there anything about AI? Artificial machine, ML. Nope. It doesn't mention anything about AI or ML in here. It is compared to interesting Vulkan. What is this? What is that right there? Oh, it's a volcano. I'm like, what does that mean, a volcano? Vulkan? Why is there a volcano there? What does that mean? You ain't a boomer. You can use it for making custom kernels. Oh, yes, that's what I want. I want to make custom kernels. How's it going, the Rick Bod? Rick Bod, welcome on in. Good to have you here. Okay, so let's get back into this. Man. Like the fun thing is really fun, really fully custom logic. Nice. Custom kernels. I know, it's what I love. I love that because we can make a mega kernel, like a mega kernel, super big. Coding a CPU simulator. Hey, nice. I want to make a small Rust kernel. Oh, hey, Jinlu. That sounds really neat. You should do it. All right, I knew it, Torva. I knew it. Malbolg. Yep, got the Malbolg kernel. I'll always mention them. It's got to mention at least once. So let's see. Did we miss anything in this tutorial? I just stopped after a while. Okay. Looking good here. You could run Malbolg in parallel. I mean, you could. If you really want to. If you really wanted to. All right, so augmenting the LSTM part of the speech tagger with character level features. Oh, wait. I want to read through this. Let's read through this. Let's read through this really quick. In the example above, each of the words had an embedding, which served as the inputs to our sequential model. Let's augment the word embeddings with a representation derived from the characters of the word. And now we're into something weird now. I thought we were just doing words. But apparently we can do the characters as well. What does the embedding even look like at a character level? Because now the tokens are 1 through 26, right? Or whatever your alphabet length is. You casually read through the RP 2040 data sheet today before my networking test. It's just about the most random thing you could have decided to read, but oh well. Did it help? Wait, RP 2040? What is that? RP 2040. What is that? I don't know what this is. Oh, Raspberry Pi. Oh, okay. Well, that doesn't help with your networking test. That doesn't even come close to helping with your networking test. Steven just ran the deploy OS error 28 no storage. Oh no. Okay, we'll have to take a peek at that later. Were you the first person you ever worked with? You were the first person you ever worked with. You're gonna remember that 40 FS. What does the 40 FS mean? What do you mean by that? What do you mean? Yeah, no, it didn't. It didn't let you take the mind off the nervousness. Okay, got it. Yeah. Those tests, they have importance. They're meaningful. with clips. Okay, we expect that this should help significantly since character level information like affixes have a large bearing on part of speech. Sure, they mean more if you put them together in words. For example, words have affix-ly are always almost tagged as adverbs in English. Oh, the ly. Oh, interesting. Okay. So if we were going to create a tokenizer, we want to take the root word and separate it from, what do you call it? Affixes, prefixes and postfixes, right? Or suffixes. That would give more meaning and intent. So if we need a better word tokenizer is what we need. That's what we could do. You hear a lot about it on Twitter. Have you heard about Hermes agent? No. Hermes agent. What is this? Self-improving AI agent built by Nous Research. Is this what it is? Let's see here. All right, Hermes agent. The self-improving AI agent built by Nous. Oops. Okay. It's the only agent with a built-in learning loop. It creates skills from experience, improves them during use, nudges itself to persist knowledge, searches on its own. Oh, neat! And builds deepening model of who you are across sessions. It runs on a $5 VPS. Hey, a GPU cluster or service infrastructure costs nearly nothing when idle. Oh, that's neat. Oh, 40 frames per second. Exactly. That's what 40 FPS, right? Hey, Zergio, welcome on in. Good to have you here. You meant the RPi 2040 datasheet. It also has 600 pages. So there's a lot to read. That's a lot to read. That is definitely a lot to read. Oh, you mean you're going to remember when you're old, groggy man. Oh, okay, Clipsmirk. You've actually changed the architecture to be something that continuously learning, like deep learning kind of sucks at that. Yeah. So deep learning, it can only go so far. And then if you have, I suppose, a context system, is that what this is? Like, how is it self-improving? I don't see how it's self-improving. Hey, Cabbage, how's it going? Am I high or what? Why is there English subtitles on English speaking stream? Am I missing something? Wait, no, you're correct, right? This is English speaking subtitles on an English stream. Is there something else? Is there something I'm missing? People can be deaf. It seems like that makes sense, right? All right, let's get back to our tutorial here. I'm curious about, so character level information, like suffixes and postfixes, right? That can add some additional detail into the meaning as it's being represented in the text that we're putting into the model. What are we doing today, champ? Hey, Karthik, good to see you. Welcome on in. All right, so we're gonna learn what we built. So we spent a lot of time building the LSTM, the long short-term memory model, right? Long short-term memory model, LSTM, right here. We're going to look at everything that we wrote. We're gonna review all the code, kind of like see what we can play around with a little bit. We're gonna mess around with the code, and then we're gonna wrap this up here, and I wanna read the rest of this because it's gonna say that we can change our tokenizer. Instead of creating a full dictionary tokenizer, which is what we did, that's what I did. I didn't even follow the tutorial. I just went for it. I'm like, I know what we need here. We need a dictionary tokenizer. Apparently, if we updated that to take word stems instead, we could have an even better LSTM. Isn't that crazy? You're gonna try to learn guitar? Oh, nice. That sounds like a good instrument. That sounds like I tried guitar for a little bit, and then I was like, I have to press on the strings a little too hard to make it do anything. And then I didn't care anymore. How'd that meeting go? It was good. We talked about numbers, and then the numbers go up. The numbers went up. Hey, Minecraft official, good to see you. Hey, Steven, just subbed. Oh, thank you for subscribing. Wanted to ask whether Hermes agent could potentially live in the cloud. Yes, that's what it read. It can live in the cloud. It can. It sure can. GCA. Oh, that's your Discord tag. All right, good to know. can do both bass and guitar. Ooh, nice. She's like ridiculously good at it. That's it. That is a very good talent. It really is. It takes a lot of effort. Thank you for the party. Thank you for the reactions, you guys. Good to have you here. She's ridiculously good at it. That's awesome. Just lost a B cell. What does that mean? Joshua, what does that mean? Of course, the stonks go up every time Steven joins the meeting. Yep, I'm on the server. GCA, nice. All right, started learning a piano. That's what I did too. Jinlu, I did piano. I was into piano. When you were like 2 years old. I did it when I was a little bit older. Your autism was showing quite early on. Hey, nice. You can shred arpeggio sweeps and brutal tech riffs on guitar. Kyle, that's pretty impressive. That is impressive. That is a lot of effort. It's a lot of effort to do instruments, especially guitar. Can you please make a proper structured course about deep learning? I am beginning. Oh yeah, Nithin. Hey, how's it going there, Nithin? Good to have you here. I'm originally autistic, not fake like all of you people. Hey, we can't tell. There's no way to tell. When did you start coding? Myself, when I was 11. I started coding when I was 11. I don't know about chat though. Chat, when did you start coding? Okay. You haven't played in years? Oh no, you gotta catch up. All right. Let's build a quick little poll here. When did you start coding? See, before, we'll say before 12. Wait, how about this? We'll say 0 to 12. And then we'll say 13 to 18. And then we'll say add option. Well, wait, actually, let's go. And we'll go 15 to 24. And then we'll say, well, actually, that's not fair. We'll just say 20. We'll say 18 plus, 19 plus. There we go. What age did you start coding? For me, I was 11. I was 11. 14 or 15. Nice. Minecraft. Teens. Nice. Yeah. You were 18 and it was by mistake. Oh no, Dina. You're like, oh no, you're coding. Oh no. I like that. That's great. That's fantastic. Whoops. I didn't mean to code. Accidental coding. We're talking about guitars now. I know, right, Joshua? Do all the mods here play an instrument? It took seriously like until 22. It's a lot. It's a thing. It's a challenge, right? You started coding when no years old, cause you haven't coded anything. Oh, clips. All right. Well, there you go. That's the one way to. I should have been an option on the poll that we just did there, right? I should have said never started. Hasn't even started yet. Well, I mean, technically, you can still answer the last option because it's like 19 plus, right? So it could still be in there. 22, nice. Any advice for beginning coders? Yes, I recommend Python. Go to the python.org website, click on documentation, and go to beginner's guide. Follow the beginner's guide, and then you can get into some coding here, right? So let's do that real quick. We'll even say Python, and you say print, and you got to print your hello world, right? This is when they say your hello world application. You do it like that. Boom, you printed hello world. And there it is, right there. Some hello world. VB script, Jinlu, nice. I did a lot of VB script too. It was before .NET though. This was like before .NET. Playing time is over, guys. Yeah. So that's my recommendation. If you're trying to get into coding, I recommend get your hello world going and go to Python because it is a prominent language in the industry, right? JavaScript, Python, Kotlin, and Swift or maybe, you know, JavaScript, right? It's a huge, right? TypeScript. So these are very prominent languages in the industry. By no stretch of the imagination am I a programmer or just love understanding how things work. Oh, well, hey, it's a curiosity. It really is. Why do we have to add the quotation when printing? Because you need to identify where the string is, right? So you can use different string quotes in Python. It's different for every language. You need to say when the string ends. So that way you know that this is a a string literal, which represents data. And the program knows to not treat that data as executable code. So you need to denote that. You have to denote it. And you can denote it with a bunch of characters, right? You could say triple. This is special to Python. This is special to Python. You can denote it in special ways. A bit of C++ and JavaScript, nice. Those are really, C is also a really prominent language. It's a big one. And then I'd say Rust is your up and coming. What's your favorite front-end language? JavaScript. It's JavaScript. And we could do TypeScript too if you want. You could. I like JavaScript, it's fine. Every mod here plays an instrument, nice. Hey, Cyber Potato, good to see ya. What is the use of groups in your textbook? It doesn't say anything about it. Well, what are groups? I don't even know what those are. I mean, grouping data? Sure, you want to collect data and aggregate it for sure. I don't know about groups though, I really don't. Why do groups have weird specific properties? I mean, usually because you're clustering things of like style together, so they have specific properties in a group, right? That's what I think. Microcontrollers, good idea, Jinlu. Python is great also. C++ with MicroPython. Yep, you could do MicroPython or you could do C++. Jinlu, good idea. That's a good idea. Using other functions, Python won't know the difference, right? So when using other functions, Python know the difference? It doesn't. It doesn't. No. It knows that it knows the difference between data, right? So there are literals. You could do one. You could do a float. You could do a floating number. You can do a string. There's other kinds of literals. There's a non-literal, which is nothing, literally nothing. There's a lot of literals, and so you can print none also. You can print one, right? Things like that. You have wish-listed Carlson on stream. Wait, what does that mean? What does that mean, Clips Merch? I don't know what that means. JavaScript, yes. Java, though, I know, right? Java. Why Java? You don't need it anymore. It's an educational tool. Java is fine for education purposes. It's academic language, you guys. Academic language. In algebra. Oh, well, I still don't know. I know what you're talking about. I've done algebra before, Cyber Potato. I don't know specifically about grouping, though. Talking about the mathematical concepts of grouping, like a set of numbers. Oh, sets of numbers. Oh, yeah. Okay, GCA. All right. I know what sets are. Look, you can do a set here in Python, right? 1, 2, 3, 4, 5, 5, 5, 5, 5, 5. And it's going to only give you, it's going to give you an error because you can't. Oh, wait. Is that, you can't, wait, oh. I thought, wait, that doesn't work? What if we did this? What if we tupleized it? Okay, there you go, yeah. So a set is a group of numbers that are unique, right? A set is a group of numbers that are unique. Java is not academic language. It sure, well, Anthony, I say it is because I don't want to use it. I don't want, and you don't need it anymore. You don't. You just don't. There's so many things that are better now. Also, if you wanted to use the JVM, use Scala, right? Or use something like, or use Kotlin, or do something different. You don't need to use Java directly anymore. It's just the language is so verbose. It takes a lot of work. It just takes so much work. Your dad's been coding Java. Oh, right. Comment commercially forever. So it is true. Java's still a thing. It's around. I don't want to deal with it. That's my take on it. I'm good. I've written a lot of Java. I have, and I don't want to do it anymore. Don't. There's so many things that are better. Do Golang. How about that? Do Golang instead. Write Golang. Carlson was the game that was hyped 3 years ago before the developer dipped. Oh, Carlson. You can send the Steam page. Would be curious about it. I'm curious about it. It's a fine language for most things. I know, yeah. Well, guys, I'm trying to you're chatting. Everyone's chatting. I'm trying to catch up here. Steven is fine with C, but not with Java. Exactly. Because C, you can actually get some performance out of it. You can get a lot of performance. Yeah, there are like shortcomings where you can make accidents like segfaults and things like that in C. You can still make Java crash. It's not like it's a perfect language either. It's not. Java runs on credit cards. That's true, Jinlo. You taught us about that. Thank you for the reactions, you guys. Good to have you here. All right, let's get back into our Pytorch. We want to get going here on this. Hope is an okay question. Make a bot hand write every script and function. or find a bunch of repositories, download them, and modify them? You could do that if you want. You could do it if you want. Banks and enterprise systems built on Java. Yeah, they sure do, yep. The migration to the other language or Kotlin or Go is merely impossible. That is true. They are stuck. They're stuck. They are. However, you can start over. Just start over. Thank you for the reactions, you guys. Only Java for our Cocoa chips. Exactly. Clips merge. Exactly. Yes, you got it. You posted a link? All right, let's check it out real quick. Carson. Oh, wait. I think I've seen this aesthetic before. I can't. If I click on this, I don't know if it's going to pull up my Steam account, so I probably won't click on it. But it will stay here. What do you do if you combine first-person shooters, parkour, and slow-mo? Milk Carlson. Milk-infused man will stop at nothing to locate his drink and drink his favorite beverage. Okay. Unique skill-based movement on the table, highly inspired by classical first-person shooter titles, set in a mysterious and futuristic setting. Fight your way out of a facility. Okay. Wishlist it right now. Is it worth it, you guys? Is it worth it? If you have function in programming languages, you know the number of elements in a given set, but how does that work? How does it work? It's a data structure and algorithms thing, Cyber Potato. I think so, right? So if you were making your own data structure, you could create your own set. You'd want to do this in C. You could do it in Python, but you probably want to do it in C. You would write that structure out, or some sort of data management algorithm, to only have a unique set, or whatever your rules are for the groupings. Bro uses counter data structures. You could do that too. You could add counters. Do you ever figure out the issue when you need to scale down with Kubernetes? Yes, we did, Zergio. We sure did. One of the problems that we were having, and we still have today, is with Kubernetes, it has a fragmentation problem. If you have pods and a non-homogeneous application set, a bunch of services, microservices, and you want to deploy them across all of your shared resources, your servers, each of your services has different requirements, CPU, memory, network, and you've got to contend with all those resources. However, each of your applications are going to use a little bit of each kind of differently. So you want to bin pack as many pods as you possibly can per node, so you get the most out of your leasing or your renting or your whatever CapEx you've purchased on your servers. You want to get the most out of it, right? When you're doing Kubernetes. However, when you scale down, you pay per server. You pay per server. So if you scale down your services, they've been spread out. Usually they've been spread out. So you can scale them down, but your nodes are still going to be running active. And if you are in an auto-scaling environment using a cloud vendor like Amazon or Google or Azure and Microsoft, you want to turn off those servers. There's still pods running on those servers. That's called fragmentation. So you need to move those pods and reschedule them when more resources are becoming available. And you need a descheduler or some sort of management algorithm to perform that for you. And so yes is the answer. Yes, what we did. What is a counter? It's a number that increments or decrements. Yeah, a counter is a variable that counts a thing. Yeah, it sure is. So whenever you add an increment, yep, exactly. A counter you can remove or subtract. You can count up or count down. Yes, computer can do that. For infinite sets, there are certain rules. Computer just plays around with those rules. They're up to you. You can define the rules, or you can follow someone else's. Well, I'm glad you guys did it. We did it. Yeah, we did it. There's still some optimizations we can do, though. There's still some optimizations. All right, you guys. Great information. Yeah, it's a lot of fun. It's a lot of fun. What if it's really, really, really large? Like it's near infinite. In math, you can still define. Yes, in math, you can mathematically outline this. However, in a computer, you have finite resources. So you can't create an infinite set. You can't. Though you don't need to create the infinite set. You can approximate it. You can still approximate in computers. You sure could. It does not exist. What a design pattern in software engineering. I know. What is it? What even is a design pattern? How can I count the numbers of elements in a set? You just do len, right? This, right? So watch this. Len in Python. Oh, and every other language has a similar thing, right? So you've got a length or a length operator, length function, or it's a what do you call it? A parameter, an element? No, a method. It could be a method of a class in Python. So you can see I created a set that has a whole bunch of numbers. It gets reduced because it's a set, unique numbers only. You can also have, I believe you can also have like a string in there, right? You can do a string, right? You can do a string as well. And so that'll count as a unique set. And if you create a length, if you do len, L-E-N, that will give you the length right there. So right here, length. And that pops that out right there. Finite set, but really large. Oh, Cyber Potato. Well, if you have enough memory, you can make them as big as you want. Oh, Haskell, yes. There's a concept of infinite lists, and lists don't have length because of it. Infinite list, that does sound nice. I know there is an infinity. Is it infinity? Not infinity. I know in JavaScript there is, right? So watch this. Node. You can say infinity. There's an infinity in Node right here, so you can see a primitive for that. So I don't know what you would do with that. I don't know why you would need it, but it's there. It's there. You can do infinity. Steven, are you a milk supporter or orange juice supporter? I'm an orange supporter. I support orange. It fits in memory if it has a hash set. Oh yeah, you could do that too. You could do that too. What if the set P has 10 to the 999? Soup. That's too big now. Hey, Cyber Potato, you went too big, but want the computer to compute the size of P. I don't know. You maybe. Could you represent that as a number? I think you actually can. I think you can represent that as a number. It'll have a lot of zeros. It'll be a lot of zeros. Milk and orange juice are both good. Nice. It fits. Have you seen a cool integrated application that helps chemists, biochemists? There is an amazing protein folding program that we see that you use at uni. Is there really? Okay. We need to know about that. Tell us about it. Tell us about it. Let us know. Like a set isn't a thing on a computer. We have a hash set. Yes, we do have, right. That's the data structure. It's a hash set. You can do that as a data structure, yep. Or you could do a, what do you call it? Hyperlog log. I like hyperlog log. Hyperlog log. Let me do a heart symbol. There we go. If you want to count cardinality. I like counting cardinality. Count cardinality. Cardinality. There we go. Hyperlog log. Look it up. It sounds like it's fake. When I first heard about hyperlog log, I was like, that's not a thing. Nope. It's not a thing. It's not. It is though. You just love how you need it for counting large numbers or cardinality of large numbers. So hyperlog log might be your answer for counting, right? Cyber Potato, check that out. Oh, that Google thing, it's so cool. It's pretty cool. I use it because we need to count numbers in the billions. We need to count cardinality in the billions. And that's like gigabytes and gigabytes and gigabytes of RAM if you do it without a statistical model like hyperlog log. Okay, so here's our LSTM. I want to play around with this. What else are we going to do today? I want to play with this. And I also want to play with these things here. All right, so this is going to be our to-do here. To-do. I want to play around with these. And let's see. I think we should. I think those are the things that I really want to mess with. Also, we were reading here that we can change how we generate our tokenizer, our word tokenizer. We can update it to create partial words. It's the same as ChatGPT, I think, right? I think so. Does using Brave plus a VPN keep me safe? It does, though it's not going to keep you safe from people seeing what you're doing. Someone's always going to be able to see what you're doing. They won't be able to see in the data, though they know by IP address what's going on. somewhere. So you're still giving people your data, not maybe snoopers, right? If you get a VPN, the exit point of the VPN is what's going to be advertised to whatever API or website that you're hitting or app that you're running. They're still going to know that you're using it. They're going to still see your IP address from a VPN on the exit. So they're going to know that you're using the system. It's not like a perfect screen. It does help though. It helps a little bit. Wait, Torva, what'd you say there? Error sense is just an error in transmitting and not actually processing. Hey, Elite Guard, how's it going? AlphaFold 3 owned by Google. Yes. Isn't that cool? And it's all AI driven. I was thinking that quantum computers were going to solve those problems. They figured out AI does it better. AI does it better, you guys. Oh, hey, how's it going? Andorra. Oh, wait, Andoa. How's it going there, Andoa? Oh, hi. It's the guy who codes without using AI assistance again. Yes, that's us. That's what we're doing. We're coding AI without AI assistance. That's what we're doing. We're doing LSTMs today. I want to read the rest of this because I'm very curious about it. To do this, we let CW be the character level representation of a word. Let XW be the word embedding before. Then the input of our sequence model is concatenation of XW and CW. So if XW has dimensions 5, CW has dimension 3, then our LSTM should accept an input dimension of 8. Wait. Input dimension of 8? Does that mean there's 8 dimensions? Can you do that? Can you do that? Stephen read Jan Lu's text. I might have missed it. Y'all, I might have missed it. Are my messages going through? Jinlu, let me see. Here, I'll show you. Let's go over here. Jinlu. All right. Check link share. Oh, I missed it. See, I missed your messages are going through. The trailer for Carlson, so you don't have to open Steam. Thank you. Okay, let's check it out. Jinlu. Let's take a peek. Okay. Let's open this into a new window. Okay. Oh, this looks cool.
Carlson, you're my prisoner and test subject. Ha 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 ha. Just kidding.
Okay.
Not really. This is your companion, Billy. Your only objective is to get to the milk as fast as you can. Well, good luck, and don't die.
So it's kind of like Portal, but without the portal gun.
Let me introduce you to Billy's brother.
Okay, Billy's brother is a bad guy. Oh, nice. Okay, so it's kind of like Portal with guns and a, what do you call it? A swing rope. That looks pretty fun. I kind of want to play that. Nice, Jinlu. Is it memes about getting milk? It seems like it. You were 6'7" when I started coding. Von Zupi, really? Really? Whoa. Kind of like Titanfall. Oh yeah, a little bit of Titanfall there. All right, a little bit of Titanfall. Here at UC Davis. Whoa, UC Davis! Hey, is that, you're in California? You're in California! Elite Guard, I was right there in San Francisco. I was in South of Market, right around 8th Street on South of Market. So I know about a little bit UC Davis. I was not far away. Wait, UC Davis, is that, am I thinking that right? You're in California, right? UC Davis is in California, right? California, yeah. Not far away. I mean, pretty like a couple of hours maybe, right? Many use AlphaFold and Rosetta. It's incredible, and I'm trying to get your own license for them so you can start doing your own mock predictions of your own custom sequences. Whoa, Elite Guard, that sounds amazing. You have to tell us what it's like, because you're working at the frontier of science right now. You're working at the frontier of science. Willie is collabed with Mr. Beast. Oh, wait, who? Oh, wait, who is that? Who collabed with Mr. Beast? What kind of Titanfall? Let's see. I might have missed some messages, you guys. Help me out. Oh, GCA? I really need guidance for your research. Oh, yeah. So send a message on Discord. GCA, send me a message on Discord. Send us a direct message on Discord. You're writing HTML by hand and copy pasting JavaScript snippets you found on the internet? Bonzupi, you're back then. You're before the AI times. You brought it back. Yes. Near Sac. Okay, nice. Sacramento, you guys. Nice. I'm pretty sure it's Sacramento, right? Elite Guard. AlphaFold sounds pretty cool. It sure does. The person you saw, Danny, who was making Carlson. Oh, got it. Okay. Understood. Nice. That does look like a fun game. You've been in Sacramento area your whole life, except a couple of years in Laguna Beach. Part of your heart lies south of Orange County. Yeah, we've got folks in South Orange County. We've got at least one engineer in Orange County. Birdman, I love getting to the Bay Area whenever I can. Oh yeah, it's okay. Maybe I don't know if you've been there recently. It's kind of a little bit. If you go to the city, it's a little bit depressing, and it depends on the area you go to, because there's a lot of activity there. That's where AI is. That's where Anthropic is. That's where OpenAI is. They're right there. I still have my condo. It's still there. It's sitting there right now. It's still there. You're a lifer. Nice, Bonzupi. Nice. Have you ever visited India? Oh, I have. We have a team. We have a team in India. I've never been there myself. My co-founder, Todd Green, CEO of PubNub, has been there many times. He's been there many times, Clipsmerge. Mumbai, Chennai, where else? A few other, the big cities, like the really big, the metropolises. I can't say where you're practically good at coding. Your specialization is Linux system administration. Nice! So do you use IP tables, Bonzupi? IP tables at Bonzupi. You use IP tables? As an Indian, some places are great, some places are just awful, but it's worth a visit. That makes sense. Maybe that's the same. That's the case in San Francisco as well. You got to find the right areas. To get character level representation, do an LSTM over characters of a word. Let CW be the final hidden state. CW be the final hidden state of the LSTM. Really? So this is like an extra task that we got to do, and they're not going to tell us how to do it. I was going to do it a little bit differently. There are going to be two LSTMs in your new model. The original one that outputs positional tag scores, or POS tag scores, and the new one that outputs character level representations of each word. To do a sequence model over characters, you will have to embed characters. Yeah, that's what I thought. The character embedding will be the input to the LSTM. So how are there two LSTMs? Are there two layers? How would that work? Hey, Mark Lemon, welcome on in. Thank you for clicking the hi button. Good to have you here. You've configured firewalls. Nice. You've used IP tables to configure firewalls. Transparent proxies before. It's been a while. Nice. That's awesome. Hopefully I don't get spammed now. Gotta get your tutorial right now. Go keep your eye out. Awesome stream, man. Oh, Elite Guard, thank you. Appreciate it. Good to have you here. Tell us as you get, I'm very curious, as you get access to that system. Word layer gets a pool of the character layer. Oh, got it. Okay, so we still, so we just we convert it into a character level, and the word translation goes away. So the input is still layered, right? Do you hear a lot of sites are banning Wayback Machine to save themselves from their past? Really? I think Wayback Machine's fine. We're not going to ban Wayback Machine at all. Nope, we're going to keep it. So I've got my website here. We're going to keep it. Wayback Machine, AI, you can do whatever you want. All right. You have two separate LSTMs. Two separate LSTMs? You mean two completely different models? Word can take a word embedding and a character embedding. do you have 2 LSTM layers, is what you're saying? Wayback Machine has the first website ever to be archived on it. Is it? Does it, or did it archive itself? Or it has the first website ever? Yeah, and they feed each other. Yes, 2 layers. Okay, got it. So if I go up here, so we're basically going to have an LSTM2, right? Or a LSTM letter and an LSTM word, something like that. Is that what that's going to be like? I mean, it'll be obviously got to change the sequences here, right? So it'll be hidden dims like this, something like that, right? Let me read this real quick. You should react to that AI robot broke loose part 2. Oh, we did. I think, did we do that? I think we did. We did the first one and the second one. It was scary. It was scary. It gave me thoughts after stream. And then run that in an LSTM. So I am, no, there is a third. Oh, there's a third? No way, really? Okay. I'll have to check it out. All right, let's keep going, you guys. I'm interested in, so there's this extra task here to do char level LSTM. Would that even work? Would that work? Would this just, did I just make it work already? We're gonna find out. Oh wait, no, obviously it'll crash. So let's do LSTM underscore word. Let's make sure it still works. Yeah, no, not word. Let's do letter. Here we go. All right, let's make sure it doesn't crash. Python full. And, oh, it worked. Okay. All right. Well, I mean, it should definitely be working. All right. Okay. Here we go. So, what if we did that? Let's try it. Where is that at? All right. So, letter and then word. Hey, how's it going there, Catholics? Good to see you. Moment of truth. Good to have you here. The music changed just in time, you guys. Just in time. Okay. You put a link of the video in the link share? Link share. Oh, yeah. We're not going to watch that. I know what that is. I'm good, Clips Merch. I'm good. I don't want to watch that right now. I know what that is. I remember. It's. I thought it was real. Like for a second, like before I knew what was going on, I really thought it was real. Okay. So let's continue on here. Let's mess around with our LSTM really quick. It's the third part. It's just. Is it good? Is it good? Okay, let's keep going. I want to do some actual coding here. So Neva says that we're going to push it like this, so I'm not sure if that's really what's going to happen. So let me do, so this should, let's see if this, I think it's going to crack. It doesn't. No way. No way. Okay, so what we can do is, this is not what I was expecting at all. I did not think that this would work. I did not think we could have 2 LSTMs here. Neva, why does that work? Does that work? I mean, we struggled so hard with this the other day. All right. I think we should do a second linear layer as well. I think we should do a layer L2 on the output, right? I think we should do an L2 in here. L2, and we'll do hidden, like that. And we should push it through on the L2. Let's see here, out equals out. And where is our, oh wait. Oh, we'll do an L2, yeah, sorry. L2, here we go. There we go, L2. We don't need to change that now, I don't believe, right? L2 simple on the output. And then we go straight over. The only thing is when I do that, it's going to give us, it's probably going to give us an error. Am I doing this right? Full LSTM. Are we just nailing it today? Is that what's going on? Like the other day, we were like struggling forever to like get it to work, and now it's just working automatically. So what does LSTM take as input? Right now it takes tokens, right? So we got a dictionary. Here, I'll show you. Do we save it? LSTM dictionary, here you go. So here's the inputs and here's our tokens. Right there. Inputs and tokens, right there. So it gives it a bunch of numbers. I tried to one-hot it, it didn't like it. It didn't like it. Obviously, it wants tokens. It wants tokens. It becomes somewhat obvious that it should work. Oh, like draw the input and output shapes. Oh, right. Let's see here. And that's naturally composable. So yeah, shape is TX. Oh, really? The old MacDonald had a farm. I know. It just popped up. I think this is green orbs again. Yeah, it is green orbs. By the green orbs. Right there. Got a little bit of music going on there, you guys. Mixing it up today. What? Use Claude Code. Hey, how's it going there? Use Claude Code? We could, although I feel like that's cheating ourselves out of learning. Don't we want to learn this stuff? Oh, Steven, did you hear about the shoe company that rebounded? Yep, they pivoted, didn't they? They pivoted to data centers. A shoe company, they're like, we're going to take all of our capital, we're going to turn off all of our factories, and we're going to set up a data center and put GPUs in it and let people pay for the GPUs. 500% increase in their stock. I know, it jumps 500%. Is that what we should be doing too, apparently? PubNub has pivoted to GPU compute. So what's the end goal for the stream today? Catholics. All right, so today we're going to be learning our LSTM. We're going to run through this extra task here. Instead of using word embeddings, we're going to use letter or character level embeddings. And we're going to tokenize our input per character. And we're going to see what the loss is. We're going to see what that looks like. That's the plan for today. Like there's also a batch, but in omitting it for brevity. I tried to do the batch. I actually got the batch working. However, I was unable to get the negative log likelihood loss to work with a batch. I was failing at getting it to work with the batch. I tried and it's like, nah. You want to do that? You can't do that. Nope. No negative likelihood loss for you in a batch format. Probably because we were batching it as, words. And so it could only have so many dimensions. When I tried to add a batch dimension, it just wouldn't go. It wouldn't go. Thank you for the hearts, you guys. Oh, you had the shape wrong. Yes. Okay, so negative likelihood log is the way. Yeah. That's what we were doing right now. That's what we're doing. You mean no, it's kind of the same pattern as with the .com bubble. The entire company currently just $29 million, and then name with AI, no employees, just 29 million assets. Boom. That's all they got to do. AI, you guys. It's kind of like the .com. It is, Torva, a little bit, yeah. Then an LSTM without batch. Batch, comma, X. Oh, Mark Lemon, you sent an invite to connect on LinkedIn. Oh, you did? What's the best way to send you a quick message? Let's find out. Let's take a look. Let's go over to here. All right. You gotta let me know what your name is. What's your first name? Mark Lemon? Is that you, Mark Lemon? No way. Hold on. Okay, that's your actual name. I see you. It's Mark Lemon. That's crazy. What about a batch TX? Yeah, exactly. That's what I tried to do. Never. That's what I tried to do, and it didn't like it. It ran through the model, though. It ran through the model perfectly fine. So it perfectly went through the model. Like it did this part here. My forward pass perfectly worked. It had no problems on the forward pass. However, once I put it into the negative log likelihood loss, it wouldn't take it in batch format. You basically want to figure out the shape of what you're asking it to predict. We tried to reshape that thing so hard. We tried so hard to reshape it. Yeah, so replace the log likelihood loss with a function that is. We could have done that, huh? I really wanted to use negative log likelihood loss. I really did. I really wanted to use it. All right, Mark Lemon, let's become friends over here on LinkedIn. All right. All right, Mark Lemon, we'll send you a message. Hello. We sent you a message. There you go. We got ourselves Mark right there. Mark, there you go. All right. Let me see if I can show that real quick. Here we go. We send you a message. Right. Oop. All right. Okay. Let me go home real quick. Let's see here. Okay. Bring this back over here and get back going to our tutorials here. Alternatively, take the last X. We could have done that. That was also like we could have done that. We really could have. But then we're throwing away all the other goodnesses, right? We're throwing away everything else. Again, dimension T is 1 in the problem. Is it? Was it 1? It might have been. I need to go back. We need to go back. It was recorded. It took us a long time. Negative log X, Y, none. Oh, is that what that is? Okay. That looks doable. We could do that. Okay. Let's continue on with our coding here, you guys. Let's keep going. Let's continue on here. Okay. Basically, you need to stretch Y to fit the time dimension of X. See, I think that probably would have been it. I think you just nailed it. Neva, I think that was it. I'm pretty sure. You got it right there. I think you did it. Thank you for the hearts, you guys. Good to have you here. Happy Thursday. We're almost to the weekend. Neva is actually right there. Personally, you think you make the model do a collapse so it has no time for the prediction. That also works. We were messing around with that. We were doing all sorts of things with our output here. All sorts of things. So many different things we were trying to do. All right. So let's see if we can reduce our loss. That's what I want to try. Let's mess around with this for a bit. Let's do 600. This is 100% CPU. Okay. Let's do 1,000. Let's reduce the learning rate. Okay. It's actually not nearly as much as it needed to be. 5. Okay. Simple a mean on dimension 1 would work too. I suppose we could have done that. That makes sense. We could have done that too. Does this really need to be 1? Okay, see, 1 is just a smidge too big, so let's do 0.7. Computer science chuds when you ask them to take a shower. True, Adam. Well, sometimes, yeah, because they're too busy with hygiene. Well, I mean, they're too busy for hygiene, right? You sent a video of something you made recently in general chat? Okay, let's take a look. What do you got over here? Factual. True, Adam. I know, right? Exactly. Ooh. I like that interface. Wait, did you make the interface? Oh, this is a remote control, WNC remote. What am I looking at here? You're tracking. Oh. Yeah, you made a remote control for Windows Media Center. Okay. Nice. That's really neat. Okay, so you've got a remote control. It looks like a web server, and then that web server is sending commands to Windows Media Center. How do you send a video in Discord? Like, do I have to get an intro or nitro? Oh, do you? Do you, Neva? Just compress the video. Oh, the video. Yeah, I think it's got a size limit. It's probably got a size limit. Under 5 megabytes. Got it. That's just a flag web app. Yeah, okay, Flask. All right, so you got some Flask Python over here, and you've got your remote control, and it looks like you're triggering those events on your server, your Flask server. And their Flask server has a connection somewhere. I don't know what Windows Media Center likes. And you're controlling it that way. That's pretty neat. You have Nitro Basics, so you can do 50 megabytes. Nice. You can also just use a file sharing service, though. That's good, too. That's a good idea, Torva. Good idea. All right, let's pop back over to our tutorial here. The Flask server just triggers a virtual keyboard inputs. Oh! That's a good idea. Yeah, that makes a lot of sense. Then the Windows Media Center just works off of keyboard shortcuts. That's actually a good idea, Jinlu. Very clever. I like it. All right. Exactly. Nice. Okay, so we messed around with our model. We added some layers. Where are we at here? We're going to do letter level LSTM. So let's change our, how do we want to do this? So our input size is going to need to be bigger and our tokens need to increase. So we're going to have a new tokenizer. We need a new tokenizer. Let's build our dictionary, a new tokenizer here. Here we go. Let's do it. Let's follow the instructions. This will be character level. Character level. And then we'll change our dictionary. We'll change it. Hey, Nike, you're back. Welcome on back. Good to have you here. Happy Thursday. We're almost to the weekend. Upload it on YouTube. Oh, yeah, that worked too. You got to upload it on YouTube. Good idea. That's an easy option. Okay. So we've got our mask, and then we need to sample over our data, and then we need to sample over our words, and we're going to sample over our characters. Or, how about this? We don't need to enumerate it, right? We can do something different. Oh, do we even need to? Wait, hold on. Where are we at here? For if word and dictionary continue, or if letter and dictionary continue. Are we even using index? We're not. So we don't even need to use index anymore. So we can just say this for word in, like that. There we go. You're uploading a YouTube? Nice. Nashville was great. Nashville? Is that like a TV show? That's also a place. It's a location. Did you go to Nashville? Nike? Is that what you're saying? Wait, you did go to Nashville. That's right. Or am I saying that wrong? Share a screen on Discord and play the video. That also works too. What do you mean of? TV or yeah. Okay, yeah. You did go. Nice. Nice. Nashville's pretty good. Okay, so that's Tennessee, right? You went to Tennessee? Tennessee, the state of Tennessee. Okay, let's see here. So we got word, and then we're going to go character. We're going to go we'll just say char in word. Word dot split. And I think we can do that. Python, we'll say hello. And I think we can say dot split. No, we have to say split on nothing. Empty separator. Yeah, it is empty. How do we split? Oh, we just do list. We do list. I think we do this right. List. E please, E. Yep, E, thank you. Okay, we do list, okay. List on the word. So for char and dictionary update, done, easy. Oh, there we go. Now we got ourselves a letter. Although we could just say 0 to 26, it doesn't really matter. 11 million gates under over 100 million frames per second? Never. What's going on? Wait, 11 million gates. What did I miss? You were born in Atlanta. Nice. I was also born in a state. I was born here. Oh, also on Discord as well. All right, Neva. Here we go. Negative log likelihood loss. Game you're working on. I'm trying to, here. Here's what I'm going to do. I'm going to open it on YouTube so we can see it a little bit bigger. All right, what are we looking at here? Python. It looks like it's some Python. Circuit viewer. Oh, circuit viewer. Is this a game? This looks like a tool. Show us the game. The game you're working on, it performs very well. Or is this like a room generator? What is it? Holy never nice. It kind of looks like a CPU. Exactly what is the game? I know, right? What's going on? What is all this? That is very interesting. Curious about it. All right. It is a CPU designer. Oh. So that is a CPU designer. So it's an official CPU designer. So are you designing a CPU? Is that what you're saying? Is that what you're saying? Oh, gladly beta test. Nice, Jinlu. Thank you for the party poppers, you guys. All right, let's get back to our coding. You're making it hyper performant, so you can actually you can make actual RISC-V. Is that RISC-V chips? And then run them. Oh, that sounds exciting. That sounds exciting. This needs to be char. So I need to update our dictionary to be this. And we need to build our dictionary using a different function. There you go. Let's print out our dictionary. Make sure that it's running. All right, so here is our new dictionary. We got ourselves a word character level dictionary, you guys. RISC-V is the next step for mobile computers because it's open source. So you don't have to pay a licensing for the ARM processors. You can have a small computer designed to run in your simulator smoothly. It would be very smooth. If you can custom design your own CPU for it, it will be smooth. Basically a visual representation of programming. It is, right? Actual hardware. Nike, isn't that crazy, Nike? I think it's amazing. Okay, so, however, our output, is that gonna work though? Is that gonna work? Let's try it. I have no idea. Let's see if it'll run. Yeah, it's not running. Where are we at here? Oh, right. Because it's letters and not words, so we have to update that as well. Key error the. So we have to split that. Okay. In our vectorization set. In our vectorize. We have to vectorize it further. So this will be old features. We're gonna have old. We're gonna have new features. And we need to vectorize it just a smidgen further. Just a smidgen further. We need one more level. One more level deep. Okay. Yeah, I like the visual representation of HDLs. Nice. The design of the actual virtual machine took me forever. Did it? And you went the wrong direction twice and you burnt a whole month on it? Jeez. Neva, you're doing crazy things over there. I mean, in good ways, right? You're doing amazing things. Not many people do what you're doing. How's it going there, team? Good to have you here, teams. Teams Radio Live. Fi's to code. We're coding. How's it going there, Impulsor? Hey, Impulsor, this is witchcraft, pretty much, right? Isn't that what software engineering is? I think software engineering kind of like it's a facsimile to, you know, magic. It's a facsimile. Okay. So 4, 4, 4. Okay, and then we need to do one more 4 here. Let's do one more 4. How do we do that? So I think we need to. It's getting a little bit much here because we have to do one extra level. Dictionary, sentence, 4 word. And can we do an extra 4? So we say 4 words. So for char in word. Can we do that? Something like that, right? We don't need about word length. Word less than the split. Oh, right. Because the sentence is fine, but it's not going to be split. It's going to be list. This is a whole different thing now. It's a whole different thing. Research and master's and PhD or computer science, second employee at an AI wrapper startup. Oh, wait, the good old AI wrapper startup? So you're using like Claude or GPT or Opus or Sonnet, maybe Haiku in there? In the coding agent space that just raised. Hey, Mohammed, congratulations, that's a good milestone. Second employee, that's amazing. Nice. You're hoping to make a working game before AI makes the code spaghetti. So far, it seems manageable, and you can figure out issues when inevitably does something. Yeah, when it fails, it's because it's gonna happen. It'll happen. If anyone wants to run the thing, nice, Neva, that's amazing. Let's take a look real quick. Oh, we got a nice little 404 there for your game, circuit game. Maybe you spelled it wrong. Let's see here. Let's go to your repositories. Is it private? Game. Lua game, small game, short game, small game. Okay. Already did. It's private. Let me fix it. Hey, no worries. I was like, where is it? I'm like, I'm pretty sure. Okay. Where do we need to go next, you guys? All right, so I want this. It needs to be this length, the full length of the sentence. So I guess we could just do ling. We don't need to list it. There's no point to list. We get the whole sentence, which is every single character. And then we need the word. It's not the word. It's... We need... This is the padding, so we have to deal with the padding here. You know, do we though? Because what is the full total embed size? It's gonna be based on the length of the sentence, of the max sentence. Max sentence length is here. Okay. Got it. Okay, so we need to do list, no, length of the string. So we don't need to do this. We need to do length of X. There we go. There we go. So that'll fix that. We're going to have to break a whole bunch of things in order to get this character level thing to work. Never fixed it? Nice. Circuits game. Here we go. CPU double buffer. The game runs in main logic on GPU since it anyway double buffer writes. Logically speaking, we have one giant double buffer setup which we write to the... You're building it right now? Okay, sounds good. So you can try it? Nice. You don't know about anything about coding and what you need to do? Start from the basics? Do I start from books or those 10-hour ones? YouTube shorts? Yeah, exactly. So I recommend at least hearing someone talk about it first. Seeing what they're doing, so you get sort of like a rough idea of what's going on. Maybe sit through a couple courses, then get your hands on the keyboard as soon as possible, right? So here is my Mac keyboard. I recommend that you get your fingers on keyboards and you have to start typing out the code, because that's what's going to really teach you. What language that you're... Yeah, that's a good question. What is your language that you're looking for? Oh, it's in Rust. If you want to learn C, the C programming language is really good. Yes, like really, really good. C is good. Stephen Blum branded keyboard. I know, right? We just done branded the keyboard, right? Or we're going to get one. Someday. Jinlu, that would be so neat. We got to set up a store. I want to start with Python. Oh, nice. So what I like to do is go to python.org and then go to documentation and click on beginner's guide. I think that's a pretty good option right there. A little bit of beginner guides for you right there. And then follow the instructions. Download and install. And then look at simple programs. And here you go. Of course, the first program is Hello World. And then you just go over here to your terminal. Open a terminal window, type Python. And then paste in your code. Boom. Easy. Easy. For C, you can recommend Computer Systems and Programmer's Perspective, the book. The book, right? Unless you want to build a mobile app. Oh, that's a good point, Kyle. Yeah, if you want to build a mobile app, you probably look at Kotlin or Swift, right? For mobile. All right, mobile equals. You want to do like a Kotlin or Swift. There you go. Geeks for Geeks. Oh yeah, and the W3 schools. Those are good ones too. Hey, very nice. I like it. All right, so we're gonna have to really mess all of this up, aren't we? We're gonna mess this up so much in order to get this to work. Okay, so we're gonna need to print out our features. So we're gonna max sentence. Here, dictionary. We can't. We need to get the letter. We just need to get the letter code. We need to get the letter code is what we need to do. This dictionary comprehension is getting a little too much. Just a smidgen much. Just a little bit. It just needs to be an array, a simple array. So I think we can do something like append. Let's simplify this. All right, for word. No, we don't even need to do word anymore. We don't. We don't even need to do word. What am I doing? What am I even doing? Index word. No, we don't need to do this. All we need to do is character. Char. Oh wait, that's the wrong one. That's the wrong one. We're gonna do this one here. Okay. This. Here we go. Right? Wait, let me read that again. Sample 0. Right. Too lower. Okay. We need to grab this here. There we go. For char in sentence. There we go. There we go. Much simpler now. It's when you search AI. Oh, hey. How's it going there, Mark? Good to have you here, Mark. Thank you for subscribing and joining the right channel for software engineering. We got Mark. Good. Welcome on in. What we're doing here is we're working on AI. We're building AI right now. Teams Radio Live. It's when you search AI. I know. Yeah, it's about the shop, basically. Referral links and products. I don't think you can actually brand them. At least for now, Torva. At least for now. I do want to set that up. Maybe it's possible. I don't know. I think it would be really neat if we could. You haven't updated Rust C in a while. Oh yeah, Jinlu, yep. You gotta do Rust up. You gotta Rust up. Rust up. Let's see. Not coding in Liquid or whatever they use. Oh yeah. Those crazy languages. Why would you ever use Shopify? Why would you ever use Shopify? I don't get it. I don't know. I don't know. We're gonna find. We've never done it before. What is the difference between software engineering and computer science? There are different depths, right? How deep do you want to go down the rabbit hole? Like Neva, definitely in the science realm, right? You're going all the way. All the way. Science goes into the theory, and it's a lot of paperwork. You go theory and into the compute layer. There's also actual computer parts, like physically. Yep, that's also true. You managed to mess up your laptop today? Jinlu, no! You wanted a proto buff without updating any other packages? Proto buff is always a problem, isn't it? Especially in Rust. I've always had proto buff problems. Windows Manager doesn't start because of proto buff? Really? No way! That doesn't make any sense. All right. Software engineering is actual coding. Yes. And then computer programming, which is the other one? The other one? Software engineering, computer engineering. Well, you code in software engineering too, I think, right? I'm pretty sure. All right, features for char in, and I need to grab the char. There we go. Do we really need to do that? Do we really? And this will be What is our sentence? Our sentence is going to be in data. Oh, so we need to get for sentence and data. There we go. Perfect. So for sentence and data, although for sample, this is for sample and data, and we're going to say chars equals sample 0. We're going to say sample 0.lower. We already have it here. And that's the chars. We got to put list. We got to list it. List for char n. There we go. We're gonna say features append. Where are we doing this at? We're doing this at right around here. So we need to put in a mask. We need to put a mask in. Oh wait. Let's do range. Okay, so we need to go about this a little bit differently. Okay. That's right. Okay, so we need to loop over this as the top level for features. Wait. Oh darn it. Okay, so no, we have to do feature. So we're gonna call this feature. Say feature equals. Okay. Where are we here? Features. All right. So we're gonna, and at the end we need to say features.append feature. Okay. Sample data features. It's going to be the maximum length. It's not a max length of the sentence. I mean, actually, technically, yes. It's the letter length. So that gives us the full input size because it needs to be consistent. And then we need to mask anything that does, or pad it. We got to pad, right? We got to do some padding. Anything that doesn't match from our vector, and that would be a pad, which is going to be the mask here, right? So we need to figure out if that's going to be the mask or not. Difference between programming and software engineering. Well, I think it's more, it's nuanced, isn't it? Because it's kind of a little bit different to everyone. So software engineering, programming, you're both writing code, but one can be more systems oriented, more algorithmic, more of a platform, more orchestration, right? I would say engineering is more about architecture and design and figuring out how to make systems scale and distribute workloads. That would be more engineering. Programming, maybe you're making an app, right? You're building something on top of architecture, something that already exists. And programming is higher level, and you don't have to deal with a lot of the low-level things. That's kind of how I'd put it. Is that like a nice way to say it? I know there's more to it. There's got to be, right? There's got to be more to it. Engineering is design patterns. Yeah, exactly, Kyle. Not even started, so you're going to take some time. Nice. You just realized that updating protobuf didn't affect KDE Plasma, which I've also installed for some reason. I guess I'll use it to fix your system. Jinlu, seems like a good plan to me. Features for sample and data. We're going to create our feature array, and then we're going to loop over our feature. So it's for position index in features. Do we need to enumerate that? I think we need to enumerate that. Keep the old, delete the new. We don't need this anymore. Okay. So we're gonna generate letter vector. All right, letters vector. Okay. Features, range, index. Do we need to enumerate this? Enumerate. Where's that? Is it word? It's index and tag. Okay, index, comma, underscore, because we're not going to need that, right? And then we need to say not features. We need to say feature. So that gets us the full range. wait. It's already a range. We don't need to do enumerate. Okay. So there's our index, and we're going to say feature index equals and then we need to get our sentence here. So we got our sample. So let's grab our sentence or chars. We'll say chars equals this. There we go. And then we need to loop through it. We need to loop through it and create a feature list here. And then we need to append it. So that way we got our full data set after we vectorize it. Okay. Sounds good to me. The feature index here. All right, so we got our features, we got our characters, and then we need to do something here. Right here. Okay, so if the length, all right, so length, length equals max sentence. We need this right here. The length of chars. Okay. So if index, let me see here, word. So it's basically this right here. So if index less than the current position, $600 pending back packages. That's quite a few. That means you're not updating frequently, are you? You've heard people say assembly is the coding language for the primitives. That is why. Well, you can do some assembly, and you're going to have a lot of fun doing some assembly. There's a lot of operations and then orders. I like the registers. I understand the registers. That's easy. And then you can call operations. So you can load data into the register, and you can perform operations on the data inside the registers. I like that. And you can also use those registers to call functions, so they become parameters when you're calling functions. It's actually pretty straightforward from that perspective. Hey, Loons, welcome on in. Good to have you here. Happy Thursday. We're almost to the weekend. Your laptop was in the backpack all Easter holiday, which was 2 weeks. Oh, okay. Well, then in that case, yeah. 2 weeks is a long time for an Easter holiday. A little late. Hey, you're good to go. You're good to go. We still have 30 minutes. So we've got time, you guys. We've got time. All right. So we've got my characters. I've got my length of my characters, which is the length of the sentence. I've got my features, which is going to be the full range of the maximum sentence for the max input size. We need to loop over all of them. And we need to see what our current position is bigger than the length. Is this the right way? So is index bigger than length? And then we need an else. So if the index position is beyond the length, then we need to add the mask here. Otherwise, we need to append the token, which will be how do we get the token now? We need to say index of the sentence. Where is that at? Data sample. The chars. Here we go. Like that. Okay. I think we did it. I think that's the answer. All right, let's see if we can print this out. So basically, you're almost talking to the computer in binary when you're coding in assembly. Also, there are people crazy enough to code in binary. So, there are people crazy enough to code in binary. When you're in assembly, you're actually above binary a little bit. You're just a smidge above binary. You're dealing with the CPU registers, and you can perform operations like add, multiply, subtract. There's a whole bunch of other operators on different data sets, probably. Then you can do jumps, right? You can do function calls. with label. There's a whole bunch of things you can do. So it's just a step above binary is what I'm saying. It's one of your favorite piano songs, really, Sergio? Nice. Fun thing about x86 is that the XOR, the racks, is shorter in bytes to move racks to 0. Is it always the 0 register that's shorter to? This first register? Encoding the instructions can matter. Look up Intel 8086 instruction set. You might be surprised. All right, let's do that real quick. Just real quick. And we'll get back to coding here. Where is this at? Here we go. All right, let's look at that. Complete instruction set. Oh, yeah, there you go. That's pretty easy. What is AAA? Why AAA? Where is that? No operands. ASCII adjust addition corrects the result AH and AL after addition when working with BCD values. So there's a bunch of ASCII in there. Oh, interesting. So you can do some text manipulation. Hey, they get some nice little text manipulation operators there. Very nice. Yeah, I'm definitely surprised. It's actually really clean, easy to memorize operation sets. You got your loop. You've got your OR, your NOT, your logic gates. Nice. You launched an Excalidraw instance just for fun. I know I won't use it. Oh, it's the whole world. I have Excalidraw right here. All the things that we've done over the years. Well, I guess just over the last few streams, really. This many instructions for a processor released almost half a century ago. Okay, that is pretty impressive. I mean, it really is. That's why people call it primitive. It goes extremely high level, but also sensitive that people are basically hitting a rock to change stuff, so it's tedious. Just a smidgen. I guess I'm starting with C. All right, there you go. I think C is great. The more time exists, the more instructions they need to add. They keep adding more instructions because they're like, we need to do more. We need to do a little bit more instructions. Just a little bit more. C is scary. It is because it can be dangerous. You can make accidents and without recovering. You can crash the whole deal. The whole deal. Play the Turing fleet. That would be sweet. Go deep into that game. Turing complete. A language that can write itself. You would see assembly in a totally different light. That is a pretty big light. Okay. So where are we? We're manipulating our data. We're turning our vector into a word embedding into a letter embedding. So that way we have our word embeddings. Or we're changing that up. Just having to make your own garbage collector is like a no-no for you, is it? I kind of like it because you can allocate memory once and then just use that memory, and it's really fast. If you don't have to deallocate or allocate more memory, you don't need to make any system calls. And system calls are pretty slow. So you're writing an application that is extremely fast. Right? Extremely fast. The power of C. You can do it. You might be able to do that too in Rust as well, though Rust is you don't really have so much control over what memory you're allocating as much, right? You kind of do. You do a little bit. It's just, you can't like intentionally do it the same way you can do it with C. There's no malloc. Okay. Characters, the length of the characters, LENGTH, LENGTH. And for index and features, we're going to get the index for the full range, and then we're going to update. You know what? We don't even need to do this. We can just do this. And then we can say feature equals an array. And then, well, you know what? We could. You know what? Let's just leave it. I'm trying to over-optimize. I'm over-optimizing. It's not necessary. How do some programs like learn check if a proof is valid? What do you mean, Cyber Potato? Are you talking about like... Oh, Banzubi, hey! You can intentionally do all sorts of sketchy stuff with memory in Rust if you want. If you try hard enough, yeah, you just use unsafe. It's called unsafe. Where did this window come from? Okay. The lean program. Oh, the lean program. There is the Curry-Howard correspondence. Basically, logic for math is equivalent to the type checking. Is it really? Okay, let's keep going with our coding here. So we're gonna append our feature set, our characters, chars, and then we have vectorized it. It needs to be a bunch of numbers. That's what we're looking for. We're looking for a bunch of numbers. So let me vectorize it now. No train. Let's vectorize it. Where's our vectors at? Where do we put those? We put them in here? Okay. Print features. Let's see what we got. Let's see what we got. Okay, and then I think we could do, let's do features 0. Labels won't matter. They're the same as they were before. Although that's gonna be weird because we don't know what we're training for on our labels. Although, well, it doesn't matter. It's a toy data set. Okay. Vector, all right, features. Let's see if this runs. And it didn't? Okay. Oh, okay, so we have some, we have something that we didn't fix here. Okay, so 42. Okay. Sentence and data. We got our data. I want this to keep working here. I want this to keep working. So it says the problem's here on 43. 43 in the split. Oh, because they're dictionary. Right. Okay. So here's what we're gonna do, because we changed how we construct our dictionary, so that won't work anymore. So let's just hide it for now. We'll hide it for now. All right. Sentence is not defined. That's fine because we can take care of that. And that is on line 51. Here we go. And this is going to be sample. There we go. How about now? Index features equals masked. Range. Oh. Right. Okay. Okay. Feature dot end. Easy. All right, that should be a little bit better. Oh, and we did it. Okay, perfect. How's it going there, Sigma? Hey, Sigma Edits. Good to have you here. Welcome on in. Happy Thursday. We're almost to Friday. We're almost to Friday, you guys. Good to have you here. Okay. So what I just did was I converted my word level tokenizer to a character level tokenizer, because our tutorial here was like, hey, here's an exercise. Augment the LSTM part of speech tag with character level features instead of word level features. So we're going to tokenize with characters rather than with words. And that's what we're doing. Great piano music, really? Well, it just wrapped up here. So I got my my YouTube Studio Play music. It's happening again. So we're going to move this. We're going to have a whole bunch of new songs happening. I think we got like 300 songs now. Before it was like 50, and now it's up to 300. Man, do you know what a gateway is? Sigma Edits? Are you talking about like routing and networking, right? A gateway? I'm pretty sure that's what you're talking about, right? I'm pretty sure. Is it that way? I think you're talking about a gateway. Like the difference between a switch and a router. A VoIP gateway. Voice over IP. Well, a VoIP gateway, I'm assuming there's some SIP trunking happening in there. I'm just saying some words that are associated with this scenario. I don't know much about it, although if we looked into it, I bet you would understand it pretty well. I bet you we would. Yeah, that's correct. All right, we're saying the right words. At least we're saying the right words. Yep. Yeah, so I would assume a VoIP gateway would be an IP address that you could connect to using the VoIP standard and transmit voice. And it has other kinds of signal processing, not just voice. It has API level signaling that lets you know when to trigger like a ring notification, things like that. Just having to make your own garbage collector. Ooh, I read that one already. I read it already. It just showed up in my vision there. You're building an app that transfers a phone to a gateway? That sounds really fun. You could absolutely do. Hey, F4, welcome on in. Good to see ya. You want to see you play the game Tower Networking. You just recently tried it on Steam and it was fun? Nice. That could be fun. Do you have to do like ciders and stuff? Like ciders, like the slashes, /32, things like that. I'm actually kind of curious. Because there's also that game like The Farmer Was Replaced, where you have to code in Python. Torva told us about this. I want to play it. I want to play it. All right, so this is incorrect here. That doesn't make any sense. There's no way. I'm expecting a lot of numbers. A lot. So, why is that not working? Why is that not working? I'm expecting my features to be huge. Features that append. Feature. And then we append here, and then we append the appending, right? So we get all of our features, our full batch. Yeah, so you already did a beta version of it and it worked? Nice! The hardest thing was the routing and the sound in Android. Whoa, that is impressive. Good job, Sigma Edits. Neva is an expert at coding, you guys. Neva knows. Neva knows. Neva is on Discord if you have any questions. How is the logic defined in terms of functions? All right, that was the conversation you're having there. The networking is abstracted, but a lot of the principles are sound. Oh, the F1. All right. It sounds like a lot of fun. It does. It sounds like a lot of fun. So in that case, we're not using real networking things like IP tables or ciders or masks or endpoints or NATs. No network address table lookups. Nothing like that. All right, you guys. Copyright's pain, is it? We play no good music. I know, only lullabies. Hey, there's still some good music. There's still a few. There's a few good songs in there. There's still a few. Thank you for the reactions, you guys. I appreciate it. I saw those hundreds showing up there. Not that stuff about routing tables and DNS, kinda. Oh, okay. So there's a little bit of it in there. That's nice. Good to hear it. Okay. So why is that so small? That seems incorrect to me. That seems very incorrect. Huh. Oh, maybe our Max is getting it wrong. Oh, wait, it's right here, Max sentence. Oh, it is, right here, okay. So that's the problem. So we need to... How do we do this? How do we do this? We need to do this differently. So we've got X data for, and then we need to say X0. And then we need to get the length of the sentence. We return that, and then we get the max of it. So that's going to give us a whole new world. A whole new world, you guys, right there. Okay. Char index, out of range. Chars. So my chars, yes, it is going to be out. Okay. Here we go. Sample 0 lower list chars, print chars. Let's see what we got here. Let's see what we got. Okay. Our chars is, yep, that looks correct to me. Okay. So the dog ate the apple. Good, good, good. All right. Okay. So that's the correct number of chars. We're gonna get the length. Let's continue onward. Also, wait, no. Yes. We do have to do 0. Okay, we do have to do 0. So that gets us the chars. Because the others are the tags, right? You got your sentence and you got your tags. Length, chars, features, index. And then where's the error at next? On line 58. Right there. We're already on it. We're on it. So here's our chars and then the index. So we need to flip these. Yep. Done. Done, you guys. Easy. Oh, we need to do it with the labels too, don't we? Well, do we though? Yeah, we do. I don't even know what the labels are going to be. I don't even know what they're going to be. I have no idea what to make them. What should they be? Teams Radio Live, you do? Okay. Don't know what they're gonna be. What do they need to be? Do they need that? No. So this needs to be a different. So that's the max length of that. I need it to be the words. So we need to do it on the words, not on, because this is the outputs. So there's too many classes here. So we have to reduce this to the words themselves. To the words themselves. And the max sentence is going to be a different. So we need to say max word count and max letter count, which are two separate things. All right, so max sentence length is going to be okay. And so we're going to say, instead of max words, we're going to say something else. We're going to say, this is going to be called max characters. Max characters. Let's update that now. It's going to be here. And not there. This will be max words. We're 3. What? Oh, whoa! Hey, we got some more. Hey, we're up to 3. Oh, over there on purple. Hey, what are you doing over there on Twitch? Who are you? Words. We're creating an LSTM is what we're doing today. So today we're building an LSTM, a long short-term memory model. This model is going to help us classify, or right now we're doing classification. We could also use it to be a generator. We could use it to generate text. We sure could. We could, if we trained it on it, we could. We've got all of our padding right here. So if we wanted to, this is our context window size. It's the precursor to a transformer. We're up to 3. Oh, wait, just kidding. Now we're down to 2. That was funny. All right, so I want to make sure to get this as good as I can. Just made a demo of the model Oasis 2.0 on link share. Let's check it out, loons. Demo of the model Oasis 2 in Minecraft? What are you doing? Hold on. Let me open this up in a bigger window. Oh, this is the AI generative one, isn't it? Okay, so this is generative AI Minecraft, right? So it takes all the inputs from Minecraft world and then it applies a generative layer over top of it. And there's a cyberpunk mode. Whoa, that's crazy. It's got buildings and stuff. That's the second version? Oh, nice. That's definitely trained on cyberpunk. It thinks that there's buildings. That's impressive. Loons, that's awesome. Also, very disorienting. You could not play this game. You could not play that game with that shader. You absolutely could not. That is not a game that you could play. Loons, thank you for sharing that video. It was crazy. The input lag was, oh yeah, so you try to move around. It's gonna be a challenge. It's gonna be a challenge. Okay, let's get back to coding here, you guys. All right, so I need my max words is gonna change. That is going to be a little bit different. We need it not to be the length. However, we want it to be the number of words. So we can say dot split like that. That'll give us the max words. There we go. That's what I'm looking for. Right there. Boom. We did it. There we did it. Okay. So, based on this detailed information, does that mean that we can start training our model on this new approach? Will it work? Let's see, where are we here? All right, let's comment these guys out because we don't need them anymore. Our debugging is done for the day. All right. Let's see if it works. Okay, so now we're on to the beginning of time where we are really gonna have to figure out why it's not working anymore. All right. We need to figure out where it's failing. Okay. Does it say where? It's not gonna tell me. It's just not. Return out. Let's try that. Also, let's not train it yet. Let's just run it through. And we won't do anything else. So we'll say continue. Okay. All right. So far, so good. And so far, so good. All right. A little bit more, a little bit at a time. Just a smidge at a time. Also, did we actually out equals, no way. We already did. Huh. Oh, well. Okay. So let's continue. Let's return out here. Let's see if we can get our first LSTM input there. All right, second LSTM input. Oh, all right, we're working good. All right, so let's just see if we can do a full forward, and we're good to go. We're good to go. Okay, this is great. This is great news. So we got our character level LSTM happening here. The first version of the model just generated images of Minecraft very fast. This one changed the look in real time. Nice. It is really neat, although it's kind of confusing. Hey, Prod by Core, good to see you. Welcome on in. It's Thursday. We're almost to Friday. We're getting really close. Okay. Let's keep going, you guys. I am interested in... So since we did a full forward pass and it looks good, let me print the output. Print out. And we also want to set the epoch to 1. You know what? Let's just do... how do we do this? No, you know what? Let's leave that here and we'll print them all out. We just need to set the epochs to 1. There we go. Okay. So that's our output. That looks good. That looks correct. I'm happy with that. I think that's good to me. All right, so let's print it out when we unsqueeze it. Okay, make sure we get the right dimensions. Yes, that looks really good now. Oh, we're looking good, you guys. We're looking good. Okay, I'm gonna grab a little bit of water and then I'm gonna continue with this. We're really close to being done. Actually, you know what? Let me check here real quick, let me check. Nah, we're so close to being done. I think I can wait on the water for a second. Okay. Let's see if we can get our delta. We'll try our delta. Here we go. Is this, yeah, that's where it fails. This is where it failed last time. So let's look at, oh, our target. We forgot to update our target, did we? We might have. So we need, let's look at our outputs here. Out shape target. Okay. Let's let it crash. Let's let it crash and then we'll run into it here so we can see. Okay, so we got a 29 by 4 because there's 29 letters. Right. Okay. That's going to be the output of it. And our target size is only 7. Okay. So I need to think about that for a second. If that's the case, we don't want to classify every letter. We want to classify the number of words. How do we that? I'm gonna watch the YouTube video. Bye. All right, Cyber Potato sounds good. All right, so we do gotta wrap up here, you guys. I think the plan for tomorrow is to figure out how to update the criterion. Well, we don't even have to do that. I think what we need to do is update it so the output of the LSTM is giving us. Can we do that though? Because the number of inputs that we're sending into it is. So how do we even do that? How do we combine the two? I don't even know. This is something that I'm not sure about. If we want to classify the words rather than, I know we can classify the letters. We could totally classify the letters, but there's no point to it. Steven, you want to pool it? Oh, okay, yes. All right, let's do the pool. Okay. Neva, thank you. I was like, why is it not working? So we need to pool it, which we do up here. So we're gonna say our pool. How do we even do that? I'm familiar with the CNN, which we have around here somewhere. Do we have convolutional? So here is our pool. You would recommend mean over dimension 1. Oh, your outputs are BTX. It can mean on dimension 1 and then get B of X. Okay. Let me think about that for a second because right now we're getting an output on every letter, but we want to get the output on every word. How would we say, for example, this is the first word right here, the letter THE, right? How do we pool on THE? So like this is the first 3 letters of the word the, right? Oh, every word, because we're doing character level, which is what this exercise was trying to have us do. So we got character level. To get the character level representation, do an LSTM over the characters of a word. And let the So we need one LSTM to only do it over the word? Just one word at a time, not all the words. Is that what we gotta do? And make a list of the character per word? We wanna do a gather and make a list of the character per word. Do a BCWX. To get the character level representation, do an LSTM over the characters of a word with the final hidden state of the LSTM. There's going to be 2 LSTMs in your new model, the original one and the new one that outputs a character level representation of every word. Do a sequence model over characters. You will have to embed the characters. The character embeddings will be the input of the other LSTM. Can we just do an embedding? How about we do an embedding? I think I know how to do that. I think I could do that. Would you rather gain riches or gain eagers? What are those? What's it? Yeah, and then just mean pool by the end. All right, I'm gonna try the embedding. So embedding, and this will be let's see here. embedding dimensions. What is that supposed to be again? Oh, it's just here. Okay. Why 12? Oh, is that going to be the output? I forgot. Is this the sequence length? No, because we've got our dictionary length and tags length. And then our what was it here? 1 second. Let's see if I got it right. Here we go. Embedding dim. What does embedding dim equal? 6? Huh. Huh. Or sum. We could do that as well. We could do the sum. I think they were trying to. We could do sum. We actually could do sum per word. We could do that as well. We could. Project structure with features you want after you made a prototype. That's the basic function. Server connections between server and computer. Or games are really good at learning more. Teams Radio Live? What? Server connections between server and computer or games are really good at... I don't know what you're saying. Okay. I don't get it. All right. So I want... So we can do a character embedding and a word embedding. So I'm going to take the output of the characters. Well, and the first LSTM. And then embed that. Okay. That might be something that we have to do tomorrow. Oh, Rebellion. Huh. Rebellion Ant. Good to see you. Welcome on in. Happy Thursday. We're going to wrap up here, you guys. I think we do got to get going. Hi. Hello. Welcome on in. All right. So we do have to wrap up here. They also made a general purpose real-time video editing model. You can use it to free in your stream. Really? No way. You put a link in the link share. Nice. Excellent. Rebellion on. Good to have you here. Okay. So I want... So can we say, what is it going to be? We need to say what our embedding output dimensions are going to be. So let's see here. It needs to be the length. It's got to be the same thing, right? So we have 2 embeddings. Vocab size, which we have there. And then we need a word vocab size. And it's going to give us embeddings there. Okay. I think I have a general picture. So I see what we could potentially do here. We need based on what it's giving us here in our hint, which is what we're gonna have to do tomorrow. I think this will be the plan for tomorrow. We're gonna try to get this exercise to work. We're gonna see if it does. I don't know. We're gonna find out. Chat has too many imported conversations. They can't keep up. I know, Neva. It's unfair. I know. All right, Neva. So we're gonna have to run. We have to get going, you guys, because I have a lot of other tasks to take care of for today. Had a lot of fun. We will be back tomorrow. The plan for tomorrow is to finish this exercise where we're gonna get our word level LSTM into a character level LSTM. It seems like it'll work. I mean, we got it to train with words. Why can't we get it to train with letters? And keep the same classifications on the words. Oh, by the way, Steven, if you need help with this later, let me know. We might need it. We might need it. That might be the plan. So we do have some problems here that we will need your help with. It might happen. It might happen. We've got a generally good idea of where to go, though. So I need to create 2 embeddings and 2 LSTMs, which I have here. And then we need to take that other embedding and then put it in the middle. We'll put it right here. The other embedding needs to go here. This will be like word embedding. And this will be the letter embedding. We need to switch those up. So that's the plan. That's the plan for tomorrow, you guys. Had a lot of fun today. See you guys tomorrow. I'm going to play around with making my laptop's boot sequence fancier. Oh, Jinlu, sounds good. The GitHub. We could do that. All right, let's do that. All right. It's going to be broken, though. It's going to be broken. Git. All right, git commit -m. We started char level. It is broken. There you go. We pushed the main branch and it's broken. There you guys go. Nice. You're gonna do a PR solution. We could have done a PR. We could have done a PR. Don't feel obligated to use it. Oh, I know. It's too late now. We already pushed it. We could have totally built a branch. I know it's not that hard, right? Git checkout -b branch name, and then you just git push the branch name. We could have done that. All right, you guys. See you tomorrow. No, I mean, you are going to PR. Oh, got it. Okay, got it. Following all the different conversations. Good to have you here. It's been a pleasure. I hope you all have a fabulous rest of your day. See you tomorrow, guys. Enjoy it. Bye, everyone. See you tomorrow. Thank you for joining.